Okay, so today what we're going to do is a couple of these problems. The first one is which of these things has the largest standard deviation? And standard deviation is like the spread of the data, so how far things are spread away from the mean. And so if you look at this, the thing that has, so if you're looking off the graphs, it looks like the means of all the graphs are around 40. Like this one's probably a little bit towards the skew, but it looks like all the means are around 40. So if all the means are around 40, you want to look for the one that has the data points the furthest away from the mean. Well, obviously this one goes out the farthest, so this has the highest standard deviation, or the ones furthest from the mean. Let's look at number 2. On number 2, it says a worn out bottle machine doesn't bottle things properly. 5% of them fill. If you randomly select 20 of those bottles the machine produces, what's the approximate probability that you get exactly 2? So this is a success fail, so it's binomial. So that's what we know from it. So since it's binomial, for binomial we always do our total, choose how many we want to get, which is 2. We then put how many successes we have, so we have a successful rate of 5%, or I guess a failure rate of 5%, but we're going to treat it as a success, and we want that to happen 2 times. And then we have to think about the percent of time that it doesn't fail, and that's going to happen 18 times. And then we're going to plug that in our calculator and see what we get. So I'm going to do 20 math probability choose 2 times 0.05 to the second times 0.95 to the 18th. And I can see that that's 19%, so B would be our choice there. Let's try the next one. So this is the same kind of idea. It's a college basketball player, and they want to make some free throws, and they're attempting it. So this is binomial again. And because it's binomial, we're going to do 4, because he's going to take 4 shots. Choose, and he wants to make 3. So 4, choose 3. And then we have a 5/6% success rate. And we want 3 of those to go in. I have a 1/6 failure rate, and I want 1 of those to be a failure. So then we would do that. So 4 math choose 3 times 5/6. Oops, put 8/6, that'd be bad. 5/6 to the third times 1/6 to the first. I guess I really don't have to put it to the first, but that's okay. And we can see that's 39%, so the closest answer to that would be 40% right there. Let's try the next one. A sample was taken of 20 employees from a large company, and the box plot shows, well, what's the median salary? Well, we just look about where this middle line hits for our box plot, so the median salary would be there at 48. The next question we get on our box plot is how many employees would be between 40 and 60? Well, because this is a box plot, we know that these are its quartiles. So we know that this is 25%, this is 25%, this is 25%, and this is 25% out here. So because we know all that, we know that 50% would be from here to here. So 50% is here to here. Half the employees would be from there to there. So if half the employees are from there to there, that should be 10. There's 10 employees that are that way. Let's try the next one. It says, what percentage of employees are from 60 to 78? Well, that's 60, and that's 78. And again, we know that each of these 1, 2, 3, 4 spaces is 25%. So we know that that has to be 25%. Now we're going to decide what situation this falls into. So we're going to check if it's Python, binomial, geometric, or normal. So it says in a recent hockey game, Sidney Crosby scored 33 in 77 games. Assume that his goal percent stays the same. What probability would he get a goal in the first game? Well, now we're checking the probability until a success. So we want the success to happen in the first game, but since it's a probability to the first success, that is geometric every single time. In this distribution, in a typical day, 31% of people in the United States go online, and they want to find the probability that the number who says they go online to get news is exactly 2. Well, anytime we want an exact number of success, an exact number of failure, since we have 5 people and we want exactly 2 of them, that would be binomial, just like we've done those other events. It says what type of situation would model it again. And it says in a newspaper they find a mean number of errors on a page is 4. Find the probability that we get exactly 3 typographical errors on a page. In this one, it's actually going to be Poisson. Even though they said exactly 3, the reason we know it's Poisson is they don't tell us how many successes or failures. They're just saying on a page. So out of this time window of a page, how many successes or failures we would get. So because it's a time window or a certain amount, and we have a mean number, we know that it will be a Poisson distribution. So if they ever say how many, assume you get 7 tornadoes that happen in a single day, or anytime they talk about a single something or interval, we're going to use that Poisson distribution. In this last one, we want to know which of these statements is true. So it says the mean is larger than the median. Well, I would assume that the median would be right in here in the middle, and because it's skewed, I'd assume the mean would be out here. So that statement is true. Obviously the opposite would be false. Obviously the mean and the median aren't the same, and obviously it wasn't impossible for us to tell because we told right off the bat that that was true. If you need help with any of the things, just let me know. And this is our third final review.